Don't know if anybody's here yet, but just give me a second to get everything moved over. And then we will get started on our day. And there's this image. Maybe we'll copy that. Yeah, that's what we'll do. Let's see. I hate that this is on the constraints. Move the constraints over too. It's a lot of instructions. And a lot of constraints. It's more constraints than I've seen. Both lists. Okay, non-descending. Anybody here yet? Let's see. Have not posted that we are live. And we need to do that. Move this over here. Disabled. At everyone. I'm live. Yep. Boom. Okay. Because I do want to also finish what we did yesterday too. All right, we're starting to have some people drop in. So we're going to be looking at, what is it called? Merge two sorted lists. And it's 21. So let's see. You're given the heads of two sorted linked lists, list 1 and list 2. Merge the two lists into one sorted list. The list should be made by slicing together the nodes of the first two lists. All right. Return the head of the merged linked list. So here's the input. 1, 2, 4, 1, 3, 4, 1, 1, 2, 3, 4, 4. And then empty, so on and so forth. All right, let's look at the constraints. The constraints are the number of nodes in both lists is in the range of 0 to 50. Negative 100, less than or equal to node value, less than or equal to 100. Both list 1 and list 2 are sorted in non-descending order, so ascending order. Don't know why they just didn't put ascending order. Sorry. Oh, and sorry everyone I had to drop so quickly yesterday. It's never boring around here. Had to go check on something pretty quickly, but is what it is. But I'm glad everyone is gonna be able to join us today. And then when we really get a few individuals back, we'll finish up what we were working on yesterday. So I have shied away from a linked list because I guess I don't even know what it is. But let's do a shot of this. You can't see that. That's on the other screen. And here is the graphical depiction of the linked list that is in the example. Let me try to move this over so we don't have as much white light on the screen. So we're given, it was 1, 1, 2, 4, 1, 3, 4. And then we go 1, 1, 1, then 2, 3, then 4, 4. Do we know if they're going to be the same length? We do not know. We know from here these aren't necessarily the same length. So we need to. So what I'm thinking is we need to iterate. So maybe it's going to be the solve of finding which list is shorter. And we're going to iterate through. So what is in my head, and we've experimented. I've redone the lighting So hopefully we can won't have constraints of lighting later. Oh, you can't see all that. There we are. So there are the constraints. I try to check the image every so often, just to know. So all right, there's. That's just one space. We can get rid of that at least. Move that up a little bit. Okay, that's better. So what I'm thinking is maybe we pass in. We're not even going to worry about time complexity right now. We're just going to get this to work. And when we have our usual suspects here, we'll go over. I'm very curious. If you wouldn't mind, you don't have to. It doesn't have to be big. Just say hey and let me know what time it is where you are, because a super majority of our group is Mid-East and East Asia, and maybe sometimes far East. But I'm just kind of curious, because I would say YouTube says 19. It goes in between. I've seen it as high as 23% is from India, and I think currently right now 19% of my viewers are from India right now. And what I think is so cool, especially having a daughter, 19% of our viewers are. Is it 19? I need to look. I haven't looked in a while. How many are ladies, young women, who are, because my demographics tend to be 19 to 24. That's how, let me look. Audience. Yeah, audience. It was under the audience tab. Oh, everything is slow today. I think that's my internet connection. I got a warning that the bit rate was already really slow. All right. And I've upped my subscriber view. Yeah, 11 point right now over the 28 days. 11% are women. Let's go back to the lifetime of the channel. Lifetime of the channel, 15.9% are women and 84. And my largest group is 18 to 24. Then my next largest group is 25 to 34. So 80 plus is between 80 plus percent between 18 and 35. I have 0.4% between 55 and 64 and 0.1% 65 plus. So that's very cool to me. All right, let's go back. Let's get going. Vinky, good day to you as well. All right, Vinky, so now that you're here, let me go back and show you how close we were to this. And we can drop this try. So we left off here. And you know how I looked at it and I was like, wait a minute, we have these extra ones. It's this right here. Look at this. We get all our extra ones. So let's go back to 4. And I still don't get why this isn't going to out index here. Let's do 4 so we can see it all. And turn that off. But look how close we were to this. This is the problem. Move this over. Did my there we go. Yep. The Pascal is solved. Yep. So it was this inner right here. I was not paying attention. I was adding the last one inside the for loop. And then I started looking at it. And I do not get why I don't need this try and accept, but I can speed this up even faster. So check this out. I don't get why this isn't out of range. I tried to go through it, and This is so fast. I beat 93% of, see, there's the solution, and we go up to 5. And this passes everything. But I was gloating on your solution. I was telling my wife and daughter about the coefficient, the x plus y to the power of row number. I get so excited, and I try to tell them things that I find funny. I know better because they don't find the things that I find funny, nor do they think that was cool. So it fell flat. But I thought it was highly impressive that you were able to see that. Your math skills are unbelievable. But I don't know why. I can't fathom why this is not indexing out of range when we get to here. I guess it's being protected that since this is something that's out of range, it just doesn't add anything to it. I don't know. I can't see it. But when I run this inside, it was like 90 faster than 93% of everything. But yeah, it was just a simple order operations issue right there. So I'm probably going to need some of your help because you've worked with linked lists before, correct? I think you've talked about it. I think I've stayed away from linked lists, but like I said yesterday, I'm going to have to take some of my own medicine today. I don't know what a linked list is. I'm terrified of a linked list, so we're going to do linked lists today. And I think I have the lighting problem solved, so we're gonna go through that. Let's see how it looks right now. Yep, don't want to do that. Not great, not bad either. But we won't have the dots later. All right, linked lists. So here was the example that they gave. So it's right here. You get 1, 2, 4, 1, 3, 4, and it returns 1, 1, 2, 3, 4, 4. Here are the examples. So what I'm going to try not to over-engineer this because I know so I'm wondering if we need to do like min and max, find which one is the smallest list, because they give an example that they will be uneven, they will be empty, and so on and so forth. So I'm thinking we iterate through, we look at this one, and then we add it to a list. So right now we need an empty list. Then we're going to be given list 1 and list 2. There we are. So that's our starting point. Nico, how are you? That is awesome. I wish I were more creative to do memes. That is awesome. Where did you end up posting the your meme? I'm very curious. All right. When we do min, we just get the min. All right, for I. Oh, I want to do this list extend and sort and call it a day. However, nodes are easy but a bit complicated in theory. Yeah. Yes, I know what I know. Let's see what it does. Okay, so if you're looking in the comments and you're seeing what Vinky is saying, I want to do a list extend and sort and call it a day. However, nodes are easy but a bit complicated in theory. So the solution that Vinky is talking about, if you happen to be brand new, well, let me look at Nico's meme.
ever look at some?
All right. I'll play. Oh, it's a video. I'll play that later. All right. Let me go here. I'm unmuted. Okay, so inside a list, I know how Vinky is feeling right now, and I think I need to do a video. I don't think people are gonna want to continue to hear me talk about these. So I think what we're gonna do today is we're gonna do this one. We're gonna record a solution for this. What'd they call this? Pascal's triangle. All right. And we'll record this pretty quickly, and we'll just probably have this here. All right. Because I got to find a balance between Pascal's triangle. All right. Let me text. Okay, boom, 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 boom. And I may get a phone call. I don't think I'll take it. All right, let's go back. Let's see who all's here now. All right. It has some music, but I don't think you can get copyright for it. It means copyright warning appears. So yeah, I'll watch it. I'll watch it later. But yeah, I just don't want to get banged up for anything like that. I guess I thought a meme was just a image, but a meme can be also a video as well. Okay, so we have a few more folks dropping in, so we're gonna record this later. But we were basically right on top of the solution yesterday. It was just we had a nested issue, and this is one of the things that I'm overly obsessed with. Overly obsessed with, that's redundant. Obsessed with about order of operations and understanding exactly what your instructions are. So I was adding a 1 to our embedded, just a meme is funny content, got it. I was adding a 1 to the list every time through the for loop. So it was like, get done, add a 1, get done. Because if you're super new, these instructions right here inside our body of our header, it's do these instructions every time through. That's basically the rule of a for loop or any loop, while loop, for loop, things like this. Now, once you exhaust the loop, then it goes, all right, then do these instructions. And then I had a loop inside a loop. So those, I'm working on the ultimate perfect verbiage for order of operations, because order of operations sounds bland, but it is unbelievably complex and unbelievably important, because we basically had a solution and it was completely wrong because I had this simple statement right here inside our for loop. That's how close we were. So, all right. Okay, back to our linked list problem. All right, so we need. Oh, we were going to talk about. Vinky's solution. I love how you said that, Vinky, and call it a day. So we had extend. So when you have a list, the way this works. So we have list 1, list 2. Now the way that extend works, it's exactly like, and I'm running help on this method. So a method is associated with an object. A function is a method that you can do on multiple objects. There we go. All right. If if it's able to, if its magic method has been established to operate on that function. So we'll talk more about that. All right. So what does extend do? Extend list by appending. Wait a minute. We know. I've got to work with my mouse. Appending elements to the iterable. So what is what? Okay. So we just used append the other day, and actually, Vinky, I was thinking about this as I was getting up this morning. We could do this all in list comprehension, couldn't we? And make this really, 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 really clean. So we could do this list comprehension and then add the two lists together. I don't know. I wonder how much faster it would be. I bet it would be, because I do default and I use for loops when I should default to list comprehension and go from there. So, all right. So we have list and extend list. So do we see anything about in place or return? So I can't remember, so we're just going to do it. List one dot extend, then list two. So list, I think it does it in place. Yes. So since it does not say return, it does in place. So it means it changed it literally, because extend list by attending. So if you read this carefully like a riddle, extend list. So it extends list to append. By append puts it at the end. Now I can show you this too. Yeah, we'll do this since I just changed list one. List two. Now, when you use this doesn't do anything because this is just output and I'm not returning it, and I'm not appending it. Now, when you append, you're augmenting, you're changing the original object. Now, when I do this, 2, 3, I added 1, 2, 3, and if you look, that this is list 2, and I added 1, 2, 3. But when I call list 2 again, it is still, I would have needed to have this on the right side of an equal sign. Then I would have created a new object while not adjusting list 2. So Vinky's solution is, let's just throw these together. List 1 dot extend list 2, then list 1 dot sort, print list, what am I doing? List 1. So technically we're done, but I have a strong feeling that Leetcode has something. Either we'll get like the extremely slowest one and be grouped in. I get this. It works. It works. And if you're building something that doesn't have a million rows or a list that isn't a million items long, do that. But side note, if you're new, do this. Get this to work. Get comfortable with this. All right, so now we're going to be, I'm not new, so I shouldn't be leaning on this. So I had a conversation with the people I was training to replace me back in the building 2.5 years ago. And they made the comment of so fast, so good. And I was like, whoa. Been here longer. If I wasn't twice as good as you, I should be fired. All right, so let's perspective. Put everything into perspective. I've been programming for, what did we decide, 11 years? Yeah, I needed to throw this together. I need to get this done. Now, time complexity of your lists, cost management, redundancy, future-proofing, all of these things that junior, senior, and architects need to worry about? Is there something that can cause this to go wrong? I'm sure there is. Can't think of them right now, but Leetcode probably is going to think of it. So let's get started. So I'm theorizing. I think I slept too much last night, or I was laying down too much and my back is hurting. So I'm probably going to have a fun time at the gym today. All right. Let's see. Oh, and I'm reaching out to some people. I'm going to be on a live stream next week, I think. I may have to do a meeting with them before, so I'm trying to get out there and get. I know I've said you're gonna start to feel like my family, where I'm just gonna talk about. I'm gonna talk about doing recording stuff for LinkedIn, and I still haven't. So I know, I get it. It has to get old, so I'm trying to stop saying it. But that's the reason why I'm trying to get so comfortable with making better and better content. All right. So lighting looks all right. I need to sit up straight. Okay. So this works. Let's comment this out. I'm not going to delete it because we want to have it and keep it. And then probably in a few... Oh, how do my teeth look? That's actually not that bad. All right. Before it gets too busy, we may do this video for today. Yeah. All right, let's get started. Maybe we can see if we can have about 3 minutes. I've found that a 3-minute video is kind of like the best. All right. Oh, Vinky, what was your solve? Did you just kind of tweak? You said you tweaked this. Oh. Or were you able to make your coefficient problem work? Because I was really intrigued, very, very intrigued and very impressed. We'll record this and then we'll go back. If you want to send it over to... Oh, and do me a favor, if you've not hit the like button, please go ahead and do that. Solving, what do we want to call this? Solving Pascal's triangle for Leetcode. Solving Leetcode's Pascal, because I think there's a number 2. This was Pascal 1. I think there's Pascal 2 and Pascal 3. Let's see. That was +1. Pascal's triangle. Problem list. Problem set. Pascal. Yeah, there's Pascal 1 and Pascal 2. Maybe we'll do Pascal 2 tomorrow or Saturday. All right. And did I get rid of... Yeah, I got rid of that. Let's run this again, and I can show you. Copy... Yeah, the memory, I do horrible on memory, but 30 milliseconds. I thought that was pretty impressive. And we can go over, when I do the video, we'll go over exactly what I'm doing. And we could probably then put this in list comprehension if we get done. If we get done with our challenge. Nico, yeah, you can go ahead and put it on the server. We can play it on the server. We don't have to down only if we have to download it. It'll play on the server, correct? Because I don't want any downloadable files, just for security and consistency. All right, so let's get ready. Let's check everything. All right. And I showed there. Because the lighting is awful when it's white. Strong white backlight. All right. How's this? Okay. All right. So here we are. Leetcode's Pascal triangle. Pascal's triangle Leetcode challenge. Leetcode 20. What was it? Why does it go away when you go to the? I hate that it doesn't have the challenge after you solve it. Oh, I just got to go back to the description. 118. Okay, let me give them credit. Leetcode code 118 Pascal. All right, Leetcode 118 Pascal's triangle. All right. I think I like that. Let's check the lighting, and then we'll record. It's not great. Well, let's run this over here. Have it at output, so there we are. And bingo. All right. And start recording. Leetcode 118 Pascal's triangle. Hi everybody, this is Sam with Python Basics. So in today's video, we're going to kind of go over one of the things we've been working on during the live streams. And I think this problem really encompasses everything about programming, problem solving, order of operations, just thinking through human brain, Python brain. So let's go ahead and get started. So if you're new here, thanks for joining us. This is what we do. We do micro videos, one subject at a time. So make sure you're hitting the like button, subscribe button, and the notification bell so you're not missing out on any of these videos. So all right, so here's the here are the instructions. You're given a number rows. That's going to be your input. And then your output, if you need to visualize it, is going to look exactly like this. But here's the output that's going to need to be. It's going to be a list of lists. And the way that this is orchestrated for your instructions is there's always going to be a 1. You're going to be bookended by a 1. So, all right, your first row is going to be a 1. Your second row is going to be 2 1s, and that's a list, another list, inside a list. So it'd be like that right there. And then, so if you were given 1, there's your output. And your constraint is going to be 1 to 30. Both ends are inclusive, because it's 1 less than or equal to num rows, less than or equal to 30. So 1 and 30 are included. Now, the way that this goes about is this 2 that is directly underneath these 2 1s, 1 plus 1 is 2. So that's the structure. Now, this 3 right here, it is directly below this 1 and 2. 1 plus 2 is 3. 2 plus 1 is 3. So now on this fourth row, it is a 1, a 3, a 3, and a 1. Now, this is where it gets interesting. This 4, same idea. 3 plus 1, 3 plus 3, 3 plus 1. So 4, 6, 4. So this is the way that it needs to be created. Those are the rules. So now the way that I went about going to do this is I looked at the constraint, and I saw that it was going to be, the lowest one it was going to be is 1. So it was never going to be 0. So I kind of cheated a little bit and hard-coded 1. And then what I did is I came through and I created a while loop. So do this until the length of my output is less than my number of rows. So that was my first thing. So then basically I kind of cheated here a little bit, and I hard coded because these two rows do not fall under the example of what we're about to do for our algorithm right here. So if it's equal to 1, then go ahead and throw in another one. All right, so I would have my first and my second row. Now, everything else is included because the output is temporary. And as we're including. So if this was 2, num rows was 2, my first one through only has 1 in it. So that's why this works for our second one. So if it's 1, then it stops. If it's 2, it does this, stops. Now, everything after falls under this algorithm of take these and add below it with a bookend of 1 and 1. So check this out. So this is how we did it. So we're always constantly looking back at the previous list because you construct this list or your next list by your previous list. All right. So then we come through and then we start our bookend. This is our first end. We're starting our new inner list with a 1. Then we loop through and we look at our first element of our object and our next element of our object. We add them together, append the list, and go through until it gets to the last item. This is how we're doing this right here. And then once that happens and once that is complete, we add one more. And here's a very important thing about order of operations. We do this, and we do this mathematically, where we're constantly iterating through and looking at the next number. And that's how I'm doing this. I'm taking my previous object, my previous list inside my list. I'm finding out the length of it. I'm getting the index, and I'm iterating through, and I'm then adding the next item, the next object to it, to then find my number, and then I'm appending. And once I do all that, then I'm doing another bookend, and I'm adding my 1 to the end of it. And here's the example that they have of, we saw 1, we hard-coded 1, we don't have to look at that. But then I did number 5 here, and I checked it, and I ran it, and I get my exact same output as theirs. And this solution right here is 93% faster than all the other solutions. So this is the type of stuff that we're doing during the week, during our live stream. So I just wanted to share one of these solutions and the importance of order of operations and just thinking through the problem. How does your human brain think through this problem? And I promise you, if you really understand what the instructions are and how to design an algorithm because we said, okay, so we got to hard code this because there's no pattern here. All right, we're going to hard code this kinda because there's really no pattern here. But everything else, there is a rigid, strict pattern of how these lists are created. And you just have to spend time thinking through. And I promise, if your human brain can write a set of instructions, you can easily transmit it and transfer it to Python brain and write elegant Python code to solve your problem. So there we go, guys. Thank you so much for watching. Please drop any comments, questions, video requests. Please join the Discord server so you can get the help that you need and deserve. And as always, thank you so much for watching, and we'll see you next time. Bye, everyone. All right, there we go. So that's done. Thank you, everyone, for hanging out during that. Okay, so that is done. Still, I'm going to dissect this and figure out why this isn't failing, because I was slowing everything down with the try. So once I took out the try, it sped it up even a little bit more. But I'm mystified of why that's not working. So, all right, let's go back here. And actually, I want to throw in the linked lists. And let's see. Problem set, linked list. What was it? Linked lists? What does it call it? Merge two sorts. Merge two sorts. Merge sorted array. Merge two. Bingo. All right. So let's uncomment this out. I just want to see if this will throw up. Whoa. Because I feel like Leetcode would have already return list 1, not 21, 1. Let's see if it even passes. It's not even allowing. It's not even allowing it. I think it's stopping it. Venki, try it. Let me know if it is allowing you to do it. I don't know what I'm missing because I got list 1, and list 2. I think it's checking against it. What does it say? Solution merge. The driver solution driver. List 1 extend. List 2. List 1 sort. Return list 1. Yeah, it's thrown up. So it's stopping that. All right. We'll continue on. Okay. So we need to iterate through all of these. So for I in range, you need to find which one is do we care which one's longer? I can't foresee that it matters. No, but we need to know how much to do this for. So we need to do max of len list 1, list 2. Oh. Sorry. Len. There we go. There we go. All right, so the reason why 6 came out was because I still had list 1 in memory being a length of 6. So length equals max, because I need to know how much. So what I wanted to do is I wanted to find the longest list. So what I did is I put inside. So max is a very max and min. And if you look right here, you can pass in args. So basically, I can pass in as many objects as I need, or an iterable, and I will find the largest number. So don't care what it is. I'm going to pass in these two numbers. So help on max. So args value with a single iterable argument return its biggest item. The default keyword only argument specifies an object to return if, I guess I've never looked at default keyword object. Default keyword. I guess I've never really looked at, so I could go in and put in put in list, and then if I pass in a bunch of lists, I would get which list is the longest. Maybe, I don't know. Need to research that some more. So, all right. So len of list 1, or list 1, then len of list 2. All right. And print length. Print. Here, let's get this up here. Print length. All right, so 3. So all right, so right now, so we need to iterate through start iterating through. Okay, I got a little bit of light, but it's way down here. Is that infecting anything? No, because it's out of sight. Out of sight, out of mind. Okay, cool. That seems to be working. Look how that changes the color a little bit. Better, worse. All right. Okay. So now that we have the longest length, don't need that anymore. If list I, just throwing this against the wall. So basically let me try to verbalize this. I want to check and see which one is greater. So basically, all right, we're always going to take list 1 and check with list 2. And then, okay, all right. And I'm going to check this index, and I'm going to check it, compare it to this index, and then figure out which one's bigger and which one needs to go in first. So right now, here, let's comment this out so you can visualize what we're doing. So whenever you have range, when you use, if I were to change this to, let's do this for a second. So you can have this, because for I in list 1, comment this out. Okay. When you have a container, so this is a container. Let's think about this for a second. Let's really dive into this. When you have a range, it's a container of numbers. When you give the container, you're going to iterate through the objects. I'm still iterating through this object. Whoa, okay. Because a range function of 3 is this, but that looks weird. But it's the equivalent of this. Python is good with this to help you visualize. This is what, so right here, list 1 is this object. The contents of this object will come out. Now when I change to this one, range, it is going to be this object because the length is 3, which is the equivalent of this object, 0, 1, 2. So when I print this right here, I get 0, 1, 2 0, 1, 2. So get in the habit of visualizing when you see a range function, it is the exact thing as this. So your temporary variable is going to be from this. So I want a range function because I want the indices. I want to look at this one and this one, which happens to actually be ones. So then we're going to look at this one and this one, this one, and this one. So I'm going to be indexing and comparing them side by side and moving through. All right. Is there any confusion about that? Let's see. A linked list can be thought. All right. Vinky sent something in Discord. If you're not on Discord, you're missing out. All right. A linked list can be thought of as a way to navigate from one point to another, similar to traveling from point A to point Z. Letters are like nodes containing two placeholders or variables, and they can be called data or values, as in they have the distance or weight priorities, and the other being the direct address. Okay, that's helpful of a node on linked list and nodes. I know like a binary tree. We're probably going to do one of those soon. I've been avoiding that. I've never done anything with it. Hang on, let me check this light because the sun is coming in crazy strong. All right, but we're blocking it all. Okay. It's down here at this angle, and we're good. All right. Actually, kind of looks pretty good, I think. All right, so back to reading of the awesome description that Vinky has sent. Direction node. Okay, so we have to find the shortest path moving from one node to another. As in, you take a metro, you can from one point to another and vice versa. It holds their direction property. Well, I think that's a pretty good description. So that's why you need to be on Discord, so you're not missing out on all this wonderful wisdom that is being shared, shared with us. So, all right. Okay. I'm going to drink my juice. Oh, more? Okay, cool. Like a tree. Yeah, like a tree, not a binary search. Many small branches. Yeah, I've seen those, and it gives me heart palpitations. So I'm hoping that maybe since we've knocked out a couple of these problems and being able to, because I really want to put this in list comprehension, and then see how we do with this, and then try a binary search and see how we do. All right, let me go back to, all right. Well, hey, everyone, we have a couple more dropping in. Thanks for coming to see us today. Do me a favor and say hey, and let me know what time it is where you are. All right. Because it is not super early morning, not mid-morning either. I'd say beginning morning of a normal day. But I've had my days started. Well, work day, 3 a.m. My getting up 1:30. That used to be awful. Used to go to bed at 7:30. Wake up at 1:30. That was crazy. Did that for like 20 years. Okay, I was getting too old to do that. All right. So right now, we're getting our indices. So now we need to check. So comment that out. Come back up here. If I won list 1, not list. This is where I got to pay attention. List 1 greater than sorry, so what I'm pausing and thinking about, which instead of finishing this line, I was already thinking, what if they're equal? Finish this line, and then we'll go and deal with the what if they're equal. All right, list 2, I. So, all right, so what did I just threw this against the wall. So if list 1 is greater than list 2 needs to go first. So then new dot append this goes first, then new dot append List 1 goes second. All right. What? All right. Elif, the reverse, they go in reverse. Everybody agreeing? Is there anybody who disagrees with this logic? Because you're not going to offend me, because this is where I'm weak. Paying attention. Okay. Bigger, small, trues and falses, like knots. True and false tests, I still, like, if you were to give me, so I'm doing all these certifications online to stay up to speed and really kind of branching over to data engineering. So when I get given a quiz, I still feel the anxiety. So I'll tell you real honest story. So it would have been about 3.5 years ago. Walmart was rolling out kind of some certification, basically to level the playing field where everyone knew the same knowledge. Well, our building was one of the buildings that had a high procedure rate of success of policies and procedures and how to attack things. Ooh, is that the answer? Is that the answer to this one? Because I don't want to look at it. Just the intro of how you move along nodes. Is this... is this something else? Okay. All right. I'll look at that later. That is very cool. So node... Yes, everyone here needs to be on Discord, because the amount of sheer just volume and mixture of... yeah, I did the row numbers and a binomial expression. Gonna send it later. This is so cool, Vinky. I love it. All right, but policies and procedures. So I knew I could run any area in the building with my eyes closed. No joke. I could run it from my house because I knew what all the information meant. So I say that we did this weeks long of training. And then we got to taking and I knew everything because it was basically built out of our building, the policies and procedures. Then we got to, okay, later today we're going to be doing the test. And I literally felt myself, because it was, one, a really big deal. If you did not pass, it was going to really be a problem. And two, everybody would know you didn't pass because you're going to have to be doing redundant training. But I hate standardized tests. I hate being tested. I hate being quantified, having to sit, and the stress of sitting down and going, what does this question really mean? Because that type of for me, induction is awful. But as you can see, I'm getting more comfortable just speaking because I know this. And I was speaking to, I think, you all about communication. Everybody thinks communication is the actual speaking of the subject matter. And I now am realizing it's the reverse. It's just you expressing the subject matter. So the more you know the subject matter, the less you care what the other person thinks, and your stress level comes down because you are the expert in the room and you're trying to share the information. And you only really get caught off guard if you're not sure. Now, if you're getting grilled or tested or challenged, then that's a whole other issue. But if you're literally the subject matter expert and you're in the room, they're looking to you and they want to hear from you and they're begging for that information. So that is one way that you can really help yourself and become a better communicator, because you really understand the material. So all right, so now what this one means to me is if it ties. So if it ties, it really doesn't matter. So I'm just going to grab this one because they can go in the same order. Because if it's greater than, it doesn't, it goes that. I guess we could do one of these. If they're equal to each other, it doesn't matter, right? You know what? We're not going to get fancy. We're going to get this to work, right? Cool. Let's just get it to work. All right. And then print new. Let's see if this works. All right. Whoa, my computer's lagging. I feel like... Okay. Yeah, there we go. I was like, I felt like that was way too easy. Bingo. All right, there we go, there we go, there we go. Okay, try. See what this does. All right, so let's see what the, before I throw in a try, because I'm not an expert at try and accept, so I just throw that against the wall. But this is where, Binky, do you have a thought on this? So an uneven list. So if it's uneven, of course it's out of range. Okay, so if we just do try, that's not going to solve any of this, is it? And you have to have an accept. I think you have to have an accept. Let's see if this works. Let's see if this works. I don't feel like this is. No way, really? Okay. Okay. That doesn't feel like that should be right. Okay. Let's try this. This feels... Yep. Here we go. So this... I knew that didn't quite feel right. So the max... Am I not getting the max and the min? I'm getting the max of my list. So why did we get to 5? All right. Okay, so what my brain says is basically we find... Oh! Doing this wrong. We do the minimum list and then extend the remainder. Binky, what do you think about that? So, all right, let's walk through this. New. Don't save. I need that. Okay, so. Okay. And then, whoa. And we have here. Nope, this won't work either. I can already see where this is going to go wrong because this is what I would do. I would do 1, 2, and 100. So what I was already doing is I was going to chop this off and then extend this to the new list. Except if this is... So I can already see this because... Yeah, check this out. Because this is exactly how I would be... How I would do... And I can see... Because I have to then find... So I know exactly how they're going to do this. 58. A sorted linked list. Actually, let's go back because we're going to have a problem here. Because check this out. All right, so I go back and forth on my over-engineering and my edge case testing. So 7, 9. We won't get the right answer on this one. Check this out. Yeah, see? This is not correct. Oh boy. So, and I'm not good at writing sort problems. I've never written a sort algorithm. I've stayed away from it because I think the one time I tried, it was absolutely atrocious. And I was constantly going through. So right now, this is a sorted list and this is a sorted list. And this fails because this is correct because this is it. Or is that part of the nodes? Is it won't be like this? Let's throw this in and see where we're gonna fail. Move this over. Return. Let's see. This should pass the first two tests. No. It is not allowing me to run max on the lists. Because is it because their list node? A linked list. It's not calling it. Yeah, they're calling it linked lists. So I don't even know what a linked list is. So that's the problem. All right. So we are not doing well with this. Because this says you are given the heads of two sorted linked lists. I guess I need to look at Python linked list. What does this object look like? Yeah, but what does this object look like? What type of object is a linked list? So that's why we cannot. That's why we cannot use sort and extend, because it is not a list. And I need to get really familiar with what a linked list and what this object is. So now I want to try something. Return. List 1, list 2. Yeah, it does. I do not even get. So, all right. List should be made by slicing together the nodes of the first two lists. All right. Merge the list into a sorted list. Link the list. A list should be made by slicing together nodes of the first two lists. Return the head of the merged linked list. Whoo! Alright, so I guess I need to look and see. And I guess this is not a very interesting subject because we've had we've had pretty much everyone drop. All right, but we're gonna stick to it, and we're gonna learn about, because I don't believe a linked list is a specific Python object. I believe it is a data structure, but we make it into, oh, I know what I wanted to do. I wanted to return what? Okay. Return list 1. I want to see what this does. It throws up. It doesn't even return. One, two, four. Wait a minute. It gives me 1, 2, 4. My output is 1, 2, 4. I'm returning. So it's stopping me from looking at. How is it stopping me? It's not allowing me to run len on return. This is weird. It's stopping me from running len on list 1. Even though it's returning it as a list. That is weird. Return type list 1. I want to see what this puts out. So I'm running. I cannot run a type function on list 1. Object list node has no attribute next. Wow. Raise type error is not valid value for the expected return type list node. Okay, so they've created this object, and it does not have a magic method for type. All right, so that's interesting. Head to tail. Head means starting point. Head means starting point. Okay. So none of the. So it has created this object, a linked list. So let's read a little bit about, because I know I did some work with stack. Delete a linked list node of a given data. All right, remove a node, delete a node. Insertion of a linked list at end. All right, a linked list is a type of linear data structure similar to array. It is collected of nodes that are linked with each other. A node contains two things. First is data, and second is a link that connects it to another node. Woo! All right. Venki, we may lean on you to solve this. So it contains a linked list contains, let me read that again. Whoa, I was hit back on the on the stream. Insert and delete. That's all. That's all you know. Insert and delete. All right. So we data and head, the data in the next, data in the next, and then null. Let me go to Python docs linked list data structures. Lists as stacks, lists as, I know I've done some stuff with stacks and queues. more on lists. So we couldn't do. All right, we may have a problem with the queue is, I know I've done this where it's pop left and pop right and append, and where we're removing stuff. So here, I'll show you where I'm reading. So I typed in, there we go. I think that's at least readable. Ugh. Too much bright. Bring this over here. That's a little bit better. Teeth going? Yeah, I'm starting to. All right, so data structures. And then we get into using lists as stacks. And then using lists as queues. And then, let's see, there's nested list comprehension. That gets pretty sophisticated. Sets, dictionaries. Let's see. All right, no linked lists. So we need to figure out. We need to understand, because I guess I do not even begin to understand what a linked list is. All right, let me move this over here. So maybe this is good and bad, because I do see questions about linked lists all the time. Okay. You're given the head of two sorted linked lists, lists 1 and 2. Merge the two lists into one sorted list. So that's the head. Those are the starting points. So we couldn't even run len on this. So it threw up. So can we zip a linked list? Let's try. Okay, let's try this. List dot zip. Who sent? Okay, I'm zipping these and see what happens. And see if that throws up. Okay, can't even zip. All right, Vinky sent something. All right, we'll try. Is that W3? Python linked lists. You like that? You like that description? Okay. Okay, single linked list, doubly linked list, circular linked list. Holy moly. All right. So this is doubly linked. Linked list implementation, singly linked. So that's okay. So back to what Vinky sent in Discord. So all right. So we have node 1. Let's take a peek at. Let's move this over here. So everybody can see what I'm seeing. Can I make this zoom in bigger? All right, let's see. How does that look? Can everybody kind of see that? That's not bad. All right, node class 1. This is Vinky's work. Very nice work, Vinky. All right, class object node. Initiate init, value next node. All right, so we pass in node 1. We call our node object 1. Node 2. Node object, pass in 5. These are all strings. Okay. Node 3, call our node object 10. All right. So now So these are methods. So when you see like dot extend, dot append, that's what these can do. So as you can see here, this is basically your list, and then you were to create a type of list. So if you were to pass a list and put in a string, that would be list for 1, list for 5, list for 10, but we got node 1, 2, 3. All right, so then we pass in, or we call node 1 dot next node equals node 2. Okay, so give me a second. Okay, so we're assigning next node. Okay, so all right. So since we're using the equal sign, we're assigning. So this method, you're assigning a value. We're assigning to next node is node. So we're connecting right here. That's what we're doing. And then node 2, its next node is 3. Got it. All right. And then here's our linked list. So current node, node 1. While true, print current node value. And then, do this little pretty. I do like that. I forget where I saw that, and I was like, that is so cool. So here we are. It's the minus and then the chevron, or greater than sign. All right, and then if current next node is none, print none, break. So, all right, while true. So we're going to be continuing to go through. All right, so while true. So what are we doing? We're going while true, next node, print. All right, I guess, Venki, I'm not quite following. Current node is node 1. Got it. Then if node, next node. Oh, okay. Because this is, sorry, we're going to be continuing on through. For some reason, I thought this was indented. And this is where I struggle with indentation in bodies. But all of this is under the while loop. So it's going to continue through, and we're testing to make sure that we're not at the end. It's not a none. So if that's how we're going to break out of the loop. And if not, go to the next node. Current node, next node. Assigning it to current node, back up here. Boom, 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 boom. So then we print out 1 to 5 to 10 to none. You got to the end of the link. There's no more. You stop. Bingo. Perfect. All right. So that is helpful. Now let's see if I can connect this to our, and I just realized I did not do another prep step today, but that's fine. All right. All right. So I may be doing a lot more research on linked lists, because that was helpful. And I get nodes and the heads of it, but I don't get the conversion. The conversion here. So this is how, this wouldn't work for this out of range, just for this classification. Even just for a standard list, this fails. So how would we even solve that? Why we'd have to look back. So we sort these. Then we'd have to look. Oh boy. How about we just even try to solve this right here? How bad's not bad, not great. But we don't have this problem up here because we solved that. All right. Since I have to learn about the linked list, how about we solve just merging two? You can't use extend, can't use sort. How about we just solve this problem right here for the rest of the next 30 minutes? Let's do that. So let's do Python brain, human brain. So basically, this is true up until that point, and then this becomes false because so we would then insert this to here and we'd be right. So this is okay if this is greater than or equal to this. Does that make sense? Let's go back over. I know that was a lot of thises. So the logic that I have highlighted is true while this index, all contents, both contents of this index is less than or equal to this index right here. So this is how you take this. So this is true in this condition. So I have a working set of logic right here for a scenario. Now I need to test, so now I'm going to embed this or move this over for a different scenario. Hang on one second, everyone. There we go. And let me leave that open because I have a horrible memory, so we'll do that. All right. If all right, so how did we deduce this? If okay, so then we have okay, so this may not be this entire logic. Hang on. Let's go back. So what happens? Let's come up with something crazy of how we would deduce this. Sorry. That's funny. All right. So let's get really... What happens if this was... Okay, that would control this a little bit. Oh, we don't have to get too crazy because this can't be shorter than this because this is a sorted list. But that can be... Aha. All right. So thinking out loud. Because, all right, let's do this. So we'd need to look at greater than, because what we're going to need to do is this will need to go in front of this. But since this is a sorted list, would it need to go more than once? Let's do worst case scenario. So, all right, 1, 2, 3, 4, 1, 2, 3, 4. Let's make this the right size. 5, and then 9. So we can have this so I don't have to worry about alignment. Let's see what this looks like. Okay. There we go. How does color look? All right. Let's see. So we got 1. So 4 needs to be over here. 1. Yeah. See this? 5 would need to be over here. 2. That's what I'm worried about, because we're going to need to check and move it over each one. And then also be incrementing. Everyone following me? And if you're not, just go, what are you talking about? I completely get it. So we've kind of shifted problems here because I got to go and do a lot of research on what a linked list is. Don't know if I'm going to have time because I've been working on this data pipeline certificate, and I have an assignment that's due today. So I may not have time. We may need to find another. Vinky, binary search. Where does that fall under linked list-ish? Is it going to have nodes and things? Because apparently a linked list is we're going to need to make another object. And for I in range length, element 1, list 1I. If I less than link list 1, else none. Ooh, I need to think about that for a second. For I in range length. Then element 1 equals, got it. Okay. Element 1 equals list 1 dot index. Okay. If I less than else none. I'm not following the else none. Not saying it's wrong. Please don't look. You've solved more of these than I have, and your problem solving is better. I just don't see that. Send it to me in Discord, because look, you've already seen me not being able to read indentation. So put that in general chat on Discord so I can see the code, because I think our problem is going to be when we get to this one, we need to move it over 1. But then when we get to 5, we need to move it over 2. Because we're going to need to, it's going to, because these both are sorted lists. And then, oh, see, I was even thinking if we have, sorry, let's just get this to work, and then I need to take my own advice. Get it to work 95% of the time. And then, so then, all right. So then if, this is if, how do we need to assign which one was larger? Hang on. I think there's something going on in our human brain, because so let's look at something. So I need to take, so if I were to have our new, let's do this real slow. So new 1 1 2 7. All right. So we know if new, so we were to redo, so we need to then insert, okay, follow me here. So then we need to check list. So we need to have a pointer that points to the previous, which one was higher. because we need to then check, we need to know which one has, all right, so let me try to verbalize what I'm saying. So as we're doing these checks, we need to create an arbitrary variable of which one is larger and which one was smaller, or which one, a marker of who is bigger and who is smaller, because this doesn't matter. This 5 and, like right here, this 4 and 8, we're looking at this, but Python doesn't know. It goes, okay, you're wanting me to compare these two, but also we're saying, hey, I also know that this index is smaller than the last index of our last list, because now this list is so much farther ahead. And how about we say that this got to 100? Something crazy like that. That's what I can see if, for an example like this, because that's what I would do. And then I would also stop. I would stop this and have this be 6 and then 9, and then maybe 50. So we would need to come through. This is exactly what I would do if I was building a challenge like this. So we would need to be a marker of, well, where'd this leave off? Ooh, last element. What happens if we put the last element in there? Because we wouldn't have to do, we could derive this algorithmically, where the next, so which list is larger? And we wouldn't have to do anything crazy, because if list 2 was larger, we wouldn't need to have it check repeatedly, because it's only going to follow itself. Now the list 1, we don't know where it goes inside the new list, and it can only move over 1. Ooh, okay. Everyone following me on that? Because since these are sorted, this isn't going to go above in front of itself, but it could always go in front of this. So this is a false sense of me saying this needs to move over twice. It would only need to move over one time, and move over one time, and move over one time as we're building this. So this let's pause here for a second. Looking at it in real time and looking at it after can be completely different. So I looked at this after this was complete, and I said, ooh, we need to move this over one time, and we need to move this 5 over 2 times. Not if it were happening in real time. As this were to get built, this 7 is here. 4 would come and check and go in front of it. Then 8. Then we'd go to the next 2. Actually, no, I'm completely wrong. It would need to go over 2. Okay. I take that back. Because then, so that needs to be a while loop. So while, let's see, negative. Let's do a list. Let's do help new dot insert. What are the rules for insert? So you can put an object, and I need to refresh my memory of how insert works. So right now new is this. So if I were to go new dot insert negative 2, whoa. I cannot believe I just did that. -2 4, All right. So it's not going to be this last one because it's smaller than this. So then we were to, and then to insert 8. So then we append new dot append 8. All right, so the new is here. Now I'm going to check and see where 5 would go. So I would automatically assume then, ooh, wait a second, what did I do? I broke this. -2, index, -2. Why did this? Whoa, 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 whoa. Nobody caught this foolishness. Let's come back up here. So why didn't this work? New -2. Okay. Because I forgot the anatomy of insert. Before. So if I want it to go before here, it's just before the last one. -1. And then new here. So then we need to do a check because I have this, which is going to be atrocious. And again, just to remind everyone, I'm not good with sort, and this is another area that I'm terrified of. So thank you for hanging out with me and being patient. Let's see. Lighting's not that bad. Okay. Teeth, getting a little dicey. Gray. Okay. All right. Is everyone hanging with me? Let's see. Vinky, do you agree with this logic, or you've probably solved a better way to do a sort? Have you written sort algorithms? What, there's bubble sort, there's all sorts of sorts. But this is going to get really expensive because how many times we're looking. Because right now, this is fine. Let's see, insert index element. Correct. Now, that was the first one where we did index 1, but everything here, then it's going to grow. So the index will move over. So we'll need to do a while loop. So if index, because also we need to capture which one is larger. Or will we embed this? Okay. Will we embed this? So that works. Then that's the order that they're going to go into the list, possibly. But if... So then that's the order that they're going to go in. That's going to go in first. If this is less than, all right, follow me through here. If this is less than, we may not need to have these everywhere. new dot. Ooh, while. Does it need to be a first or after this? Index. Index equals -1. While negative index okay, so what I'm trying to do is basically check and see, and if it's smaller than this, index insert. I want to see something. New dot insert -1. It's going to be before. It's going to be before -1. Well, index is less than, well, because so what I'm trying to do is trying to design this algorithmically, because I need to get 5. So I did 1, 2, then 4. 8 is going to go at the end because it is larger than, of course, 7. But when we got to 5, it needs to move over 2. And while then index minus equals 1. Insert let's try this. Did I do the right one? Let's get these to be the same size. And then we'll deal with the size later problem. Was it 9? What did we have the last one doing? We had these two. Copy, paste. All right, let's try this. Don't know how much more. How long have we been on? Okay, that didn't do it. All right, let's see how long of a stream do we have? We're at hour and 51. All right, so what we're doing is kind of a variation, because I found out that I know nothing about linked lists, and I'm gonna have to do some research. So we kind of stumbled across, if you're just joining us, a kind of a sort problem, because I've never written a sort algorithm. I've stayed away from them. I've shied away from them because they terrify me. But we're kind of going through, and we have 2 sorted lists, and we're not going to use extend. We're not going to use any of the built-in functions. So I'm trying to design an algorithm that will sort this. And right now, as you can see, we have them going in order if they were of pretty. Let's see. It would work. I think we have it work with this. Let's do this one. And then if we add 4. So as long as the last element is not larger than, it works. What? Why did that not reset? Oh, because we did not do new. Comment, just kept adding. There we are. So this little sad little algorithm works for this. But when we really throw some ugliness into it, where we start this is sorted, so this is a sorted list, and right now we're basically just comparing these two. And I'm trying to go and say, well, hey, we need to look at the previous end, and we need to move it over. And I may be making this, well, no, I'm not making this more complicated. So if we do these two, the first time through, 4 needs to move it over 1 index and be -1. But then the next time through, 5 needs to be moved over 2 indices. If that makes sense. Because, and I don't want to use sort, I want to just go through and do this. So what I'm thinking is we come here and we need to get, oh, Venky's got something. Venky's probably already solved this. Is it the answer? Okay, I don't want to look at it yet. But if you do want to see, probably it's at how quickly, well, we need to devise our own check and employ time. Oh, I need to leave that open. Leave because I need to remind me. I don't want to yell at my device while I'm on with y'all. So it's probably very, very cool. Let's see how long we've been on. Hour 54. Ooh, I'm getting some red on my OBS. Let's see if it's giving me a warning. You did use sort? Okay. I get it. you were ready to cash out with this early on. I loved how you put that. I'm gonna read this. I want to do the list extend and sort and call it a day. That made me laugh. So I love that. But I need to improve on my sorting algorithm. So when I get a interview, I need to probably at least speak to some sort of sort, because I've heard horror stories that there was a meme about interview questions. It was going through like this horrible course. It was like a lumberjack course about doing all these cutting, hitting with a axe, and then a chainsaw, and then this, and then this, and then the job. It was them in a kitchen, and they had an extremely sharp knife with a nice cutting board, and they were cutting an apple. And I was like, yeah, I can see that. But they want you to be prepared and be able to handle stress and be able to handle something that you've never done before. And that's what I probably learned the most, is that you're going to get asked to think about something that you've never thought about before, because a business partner needs an answer, or they're like, I don't know what to do with this. This is what I need. Here it is in my human brain. Please help me get it out and design an algorithm to do this and automate this for me. And that's what the cool part is. All right. So we'll spend a few more minutes on this to see if I can get this out of my brain, because not super good with while loops, and you just saw me read Venky's elegant solution with nodes. So do something until. So basically what I'm saying is, all right, so that's not necessarily the right way. Less than new index. Because list 2 aha, let's change this to 1. And I went the wrong way. Let's see what this does. Still doesn't do anything. All right. If list 1, all right, so let's, list 1 is because we want to get this to the 2. Let's comment this out. 1 and 1. Let's put this in a tuple so we compare. Then 2 and 7. Now here's where the heavy lifting needs to go. 4 and 8. All right. So if list 1I is greater than this, do that. All right. If 1 greater than this, do this. So we're going to be down here. Aha, 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 aha. That's why. All right, let's try this. All right, okay. So insert. Yeah, I'm failing. Okay, list 1I into index. Okay, all right. We're getting close. This is why writing this out. Whoa! And I have this backwards. We're getting close. This is why drawing them out and seeing how you're doing this. All right. We're getting warm, but my indices. So I moved this over way too much. All right, let's find out why. Let's find this out. Why? Put this down here so we can see, because this helped me last time. All right, so now all right, so basically no, this is going to be a whole different set of instructions. I'm completely wrong. Whole different set of instructions. So let's get these back, and I'll explain why I'm saying this. Let's get rid of this. Get rid of this. So now, I do want to keep my index. So I don't think so right now I think I had a shadow thought of which one was larger. So because if so, walk with me through this. Let's get the whoa. Let's get this working. Okay, append. I thought I got back to here and run. So we know that this is the larger list. This will go after this one. Since this is the smaller list, this needs to be checking. So this is 2 buckets. Possibly. and then we can maybe clean this up. All right. Let me look at something. Just had a thought. I do want to do this column one and do a video on that. I think that was a good one, especially with Vinke's math. I want to highlight that because that's some great stuff right there. All right. Let's go back here. Let's go back here. So this being larger. So larger. List one. List larger equals list two. So walk with me through here. Larger. Do we care? No. So this works. Pointer technique might work, I assume. That's exactly what I'm thinking. And I'm going to cheat and use the larger. So with me, I'm going to take the larger list. So this would be larger. And if list 2 is larger, I need to then move this over in our new. So let's kind of walk through this manually. And then we'll kind of wrap up because I think I just passed 2 hours. Yeah, 2 hours. We can do this a few more minutes because I need to keep moving. I'm trying to get out of the house earlier and earlier so I can get some stuff done. And I need to work on that certification and solve this. The pipelines are pretty cool. It's unbelievable. I thought I was impressed with GCP, Google Cloud Portal, GCP. Yeah. BigQuery is in GCP, but the amount of tools that are also inside of GCP, data procs, and you can use PySpark and all of those things. Super, super, super interesting. But all right, I completely agree with the pointers that, and I'm going to cheat and kind of use this as the pointer because if this is true, then I need to take the opposite. So, and actually we might do smaller. If smaller true. Ooh, if smaller, or if, here we go. Larger, bingo. Larger true. 1 larger, 2 larger. Nope, I need to have the same variable. Tie true. I don't know how. Okay, we'll go back here. Larger equals false. Because wait a minute. Okay, let me do something. Because this is where I'm. Because Boolean tests are very cool. All right, if list I greater than. Yes, 100% agree. Now, but we have to control the index of where this would go. Because right now we need to do a test and look at the previous and look at in new and the last item. So right now when we get to here, ooh. Because what I'm trying to do is I'm trying to design this where when this is true, also we need to look at the last item, and then if it's less, yeah, that's it. Because I need 4 to go in front of 7. While true, okay, L list I less than new index. I'm so close here. Then, because right now, if we were to do this right here, so new equals 1, 1, 2, 7, 1, 1, 2, 7, 1, 1, 2, 7, close. So then new equals -1. Then list 1 index 2 is 4. So new list index 2. I want to see something. Okay, what type object is not subscribable? Oh, list 1. List 1. There we go. False. All right, so then we're gonna go. All right, so I have this backwards. So I need to do an if, not a while. But it doesn't matter. Okay, an if, then while. If, then while. Because if this is less than this, yeah, okay. If else. And then we might be able to clean this up. And this is the reverse. We may need, let's do it down here and we can get rid of this. I don't need this. That was going to be overcomplicating. Get rid of that. Get rid of that. That was bad. This is the wrong scenario. So move this over. Control Shift Tab. There we go. Let's do it in the scenario where we would need to actually have it. All right. If list I1 less than new index. else do this prettiness. Else. There we go. Move this over. All right. So if this is true, then we need to take the index and move and shuffle it over. So right now we have our new, right? New, where's new? Holy moly. All right, so new. There. So right now we have new. Then I'm checking to see if, because if this is less, so right now we're at I2. List 1, 2 less than list 2, 2. Right? So it is true. But is also list 2 less than, aha. So is it less than list 1? Then I need to check again. Is it less than list 2? No. See how we're doing? So new list. Here we go. So while. So it's an if while. While list 1. And this will reset to 1. We've automated this. So we're going to reset and look at the last element of the list. And if it's still less, we're going to while this is true, index minus 1. If you're not following me, raise your hand. Then we do this. That's going to go at the end of the list, but this is going to go insert into index of this. Let's see how close we are. I've got to change that. Let's see how we are. All right, so we need to tweak this a little bit. This is... All right. Let's make this smaller so we can see what's going on. All right, so 4 is moving over too much. There we go. Okay, so this is an order of operations that I'm going to try to get out of my head. So what I'm trying to do is we're moving over too much. So I'm setting. So I know I'm really, really close on this. So it's exactly indentation, order of operation, just like we were the end of yesterday, where we just had an indentation here and we had an extra 1. So I can feel this because we have 1, 2, 4, 7. So right now, so first time through, we have so this is supposed to be triggering. So I'm going to print yes. So I like to do this to see if I'm triggering where I think I'm supposed to be happening. So I have yes. Here I am. So I'm moving this over too much. So, all right. So if that's true, I needed to insert there. And but then if I go to 0, let's see where I am. Now I'm not moving. So, all right, my math is I'm leaping from not moving to moving. All right, so the dilemma is while true, I need to move it. Oh, that's my dilemma. My dilemma is, so here's my math. So my algorithm is flawed because right now I'm putting it, I'm checking the index of 0. All right, so let's design this very pretty. So I may have a problem here. So this is a perfect example of maybe hard coding -1, and then after that, if it's still less than that, then we get into this loop of checking -1. Yeah, if, else. Do I need to do another if? This is why I'm not good at sort. I'm 100%. I'm not an expert at sorting algorithms. I've not written a lot of them. So you're getting to see me do this live. And that's good, because that's good for you. It's good for me to not freak out while I'm live streaming, which sometimes I do kind of lie to myself. And I'm like, I'm just putting this out on the internet. Nobody cares. But y'all are here to support me, and I really appreciate that. Let's see, how many people have jumped on? Okay, cool. If this is the first time you're joining us today, thank you for joining us, and I'd love to know what time. Don't tell me where you are. Tell me what time it is where you are, so we can keep our anonymity. All right. So my dilemma is the logic is clean, but the conversion between human brain and Python brain. So right now, this is wrong because I'm setting this to 0. So is this greater than this? So this is the flaw. But then my loopiness is if, while true, Okay, so I need to decide, but this has to be -1 because unless am I going to do something like hard code the last object? Oh, wait a minute, I am. So I'm triggering this. If this is less than this, then while this is true, check. So if it's still, okay, if this is, so we're here. So the problem is in here. It's basically sound, but some always starting out is where it gets a little bit ugly because I'm trying to find the proper index. So while this is true, subtract oh, this is so close. This is so close. While less than -1, check if because we need to know how far to move 4. And right now we're checking and then we're checking again and we're adding 1. One of the so let's sit here and go human brain, Python brain. So what am I doing? I have new equals 1 1 2 7. All right. So now is list, and I'm in this one because 4 is less than 8. We're here. So 4 is less than 8. So now, if okay, we're going to flip these. So let's walk through human brain here. So let's track exactly what we're doing. So I'm here in this bucket right here. We've got to clean this up. I'm having an instinctive feeling that these are flipped. So let's really go through our human brain. What am I doing? I'm taking my 4. Oop, I'm right here. Sorry, lied. My 4. I'm checking to see if it is smaller than the 7. So I've got to then check and see, is it also smaller than this 2? No. So because if it is, while this is smaller than that, oh, wait a second. Here it is. Hang on. Let's try this. All right. Boom. Okay. Here we go. Let me walk you through. Because we were doing this human. This is, I can't emphasize this enough. And I'll walk you through exactly what we did. And we can test this again. I'm right here. Let's go back. Bingo. All right. So new. I'm at my 4. Is 4, I'm right here. Is 4 less than 7? Yes. All right. So we're here. Now, is it also less than slide over 1 index? So we're already in this bucket. We're checking here. Is it also smaller than this? No. Cool. Do this. If it is, we come right back up here and we change its index to then -2. So it would go right here. It would go in front of this. And if it's not, was that a new comment? If it's not, stop and do here. So now let's check this. What do we have? 5, 5, and 9? 5 and 9. Now let's check because we need to move this over 2. Bingo. Now we can get rid of this yes. So this is a perfect example of what was the order of operations of what my brain was doing. So I'm dumping into here. I'm checking to see if it's the last one. So now let's get, and maybe tomorrow we can handle, let's do a couple and see what happens. Now we're not handling the reverse. We would need to do this exact same thing up here, just flipped. 99. No. 89. 91. 101. Is that right? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. All right. Let's see if we got it. 1, 1, 2, 4, 5, 7, 8, 9, 89, 91, 101, 100, 101. Okay. Well, cool. Now, we would need to adjust this accordingly, and we are also not handling unmatched. But that is the basis of a list with a little bit of sorting. So I guess, well, again, look, if you can design the rules and understand that, look, we're going to talk about this very soon. Our brains are doing more than you think. And you've got to understand, well, what did I really do? So when I was here, what was my test? What was my brain really doing? And then you have to articulate it. So I was checking the next one, and I was trying to do this all on one line. So I was here. Is it smaller? Well, then I was like, okay, so 0, is it set it to 0? No. I'm also then checking really subconsciously, and I was not verbalizing it, nor was I realizing what we were doing. We've got to do this. We've got to do that video tomorrow. So to know what to check to change the index, because we were already saying that if it's smaller, it's going to go here. But then we were also saying, all right, well, do I know if it goes here? But I'm also really, really quietly and really subconsciously checking, well, is it over here? Is it smaller than this? And we were not doing this because we're doing this test. I was thinking it was this, but no, our brain was going, well, do I need to really change it over here? Because if this is also smaller, I need to change the index. Not change the index if this is smaller. We need to change the index only if it's smaller than this one. That's what our test is. If it is, we move it over here. That's where our index. And then we're also saying, okay, now here's where it's going to go, but does it need to go one more over? And that's what this is doing right here. Let's print index. Let's print this so we can see what this is doing. Is it not printing every single time? What? This should be printing every single time it came through. Because if we look at this, this is constantly moving. Oh, okay. Let's change this to 59. No. 99. Here we go. 97. 98. Okay, 1, 2, 3, 4, 5, 6. Yep. This. I think I just touched my. There we go. Okay, I'm still not satisfied that is every single time it's moving over, because here I guess we need to make this a longer list. There we go. 8, 9. Let's make sure this is in order before I say that we've done this and we're not doing this properly. So 1, 1, 2, 4, 5, 7, 8, 9, 98, 99, 100, 101. I guess I was expecting to watch this increment up from every time through. All right. We got our sort. We're doing this. Now we would need to tweak this because if we were to flip these, it wouldn't work. But same basic principle. So all right, I think we're at 2 hours and 33 minutes. Oh my God, I gotta go. Okay. Thank you everyone for joining today. Close that. Thank you everyone for joining today. If you've not joined the Discord server, please do that. If you have not subscribed, please do that so you don't miss out on any of these videos. We're going to talk more about human brain, about how our brain is doing more than you think, because this test right here is a very valid point, because I was not designing this properly and I was not thinking through, what am I really doing? This is what am I really doing with my human brain? Boom. And then I will do some LinkedIn lists. Probably not going to be ready for tomorrow, but we will find a very cool Leetcode to do that we can do and solve. But we solved sorting a list without using, what would that be? Because we could also just do this about uneven lists. That would be awesome. I would have a panic attack. But all right, let's see. Anybody dropping any comments that we need to address? Anything pressing? We're already way past time. But thank you everyone for joining. And I will see everyone tomorrow. Bye everyone.